To describe transformations of graphs, I've categorized them into two separate lists. So if we do something to the whole function, the graph will move vertically. And if you do something just the value of x, the graph is going to move horizontally. Okay, so I'm going to go through some examples first. So on the left here, you can see the line that I've already drawn is represented by the function y equals f of x. And I'm going to now draw the function y equals f of x plus a. Now you can see that I'm adding a on to the whole function. So now this can be described by a transformation. So if I have y equals f of x and I want to plot y equals f of x plus a, the whole graph is going to move up by the value of a. So the whole graph is going to move up. So y equals f of x plus a will be something like this. And you can see that that is a translation by the vector 0, a. I've not moved anything in the x direction, but I've moved up by the value of a. Now, if this was y equals f of x minus a, I would then move down vertically. Okay, if we then do something just to the value of x, so you can see on the right hand side here, I have the function f of x again, and I now want to plot y equals f of x plus a. So now I'm doing something just to the value of a, not to the whole function. Okay, this is going to be the opposite of what you might expect. Now you might expect this to move along a units on the x-axis, but it's actually going to be the opposite. It's going to be a translation by the vector minus a, 0. I'm not going up or down in the y-axis at all, but it's the opposite of what you would expect. So actually, I'm going to move to the left by whatever value a is. So my function y equals f of x plus a would look something like this. And I'm going to demonstrate this using Desmos. So if we have a look at Desmos here now, say I plot the function y equals 3 to the power x. Okay, this is going to give me this blue line here. If I then do y equals 3 to the power x and I subtract 5 from the whole function, has been translated by the vector 0, negative 5. The original line crosses at 1, and if I move 5 down, the new line is going to cross at negative 4. Now if I then do y equals 3 to the power of x take 5, if I subtract 5, I'm only doing something to the x value, and it's going to be the opposite of what I would expect. So I'm going to have to move 5 along my x-axis. Remember, this blue line is the original. If I get rid of this green line here, the blue line is the original, and if I move along 5, my graph is going to look like the purple line here. So that is when we add or subtract values. What about then if we do a stretch? So we are multiplying the function by a constant a. Okay, so as you can see on the left hand side, I've got the function y equals f of x. If I multiply the whole function by a, that's going to be a stretch in the y direction with a scale factor of a. Now this is only going to affect your y values. So just imagine your y values are just being stretched like this. So your y values are being multiplied by the value of a. That's a stretch in the y direction. If I multiply just the x value by the constant a, that's going to be a stretch in the x direction by a scale factor 1 over a. So again, it's not what you would expect. It's not a stretch in the x direction by a scale factor a, it's going to be the reciprocal of a. So remember, whenever I do something just to x, it's the opposite of what you would expect. So what I mean by a stretch in the x direction is think about this function here just being squashed together. So stretch in the x direction looks like this. And I'm going to demonstrate this now on Desmos with the graphs of y equals sine x. So if I plot y equals sine x, and I just multiply the whole function for it by 2, that will be y equals 2 sine x. Now remember, when you multiply the whole function, it's a stretch in the y direction. So your y values are being multiplied by, in this case, 2. So it's a stretch in the y direction. If I then just do multiply the x value by 2, so y equals sine of 2x. Okay, I'm going to get rid of the y equals 2 sine x. You can see the difference here. Your y values haven't changed. It's not been a stretch in the y direction. It's been a stretch in the x direction. You can see that your graph is becoming closer together, and it's being squashed in. So that's a scale factor of 1/2. Moving on then finally to a reflection. So if I have the function y equals f of x, and I'm now want to plot y equals minus f of x, that's a reflection in the x-axis. That -1 is for the whole function. So if I reflect that in the x-axis, it's going to look something like this. If I only make the x value negative, so y equals f of minus x, that's going to be a reflection in the y-axis. So my graph would look like, something like that.